Hello everyone. Let's understand our seventh program in the computer networks lab. The problem statement is simulate the transmission of ping messages over a network topology consisting of 6 nodes. So we need to create 6 nodes and we need to simulate ping messages. So what is a ping message? So ping message is used to check connectivity between two nodes. Okay, so if you have a system and you want to check if that system is reachable to another system, it could be a system in the same subnetwork or it could be somewhere in the other part of the globe connected via internet. If you want to check if there is a good connectivity between two nodes or two systems, you use ping message. So from one system you just give ping, and this IP address is IP address of the remote system. So when you give this command and hit enter, an ICMP echo message will be sent to that remote system. So this need not be server always, it could be another node. So it sends an ICMP echo to that remote node, and this remote node, on receiving the echo, it just echoes it replies with echo reply. Okay, ICMP echo reply. So this way the communication between two nodes are successfully tested. So if ICMP echo is sent, and this will respond with ICMP echo reply. So from our system where we gave the ping message, it receives a packet. So this is how we check the connectivity. So now using NS2 we need to simulate this ping. Okay, we are not supposed to use the ping command. We need to simulate this ourselves using a 6 node network. So let's look at the program and understand how we do it. We have already worked on a couple of simulations already, so this should be easy now. So the first step is usually creating a new simulator, and then we are using two different color codes. We will see why we use these two different color codes later. And then we are opening two files, 7.tr and 7.nam, for writing the traces. Okay, all general traces are written into 7.tr. All network animator traces, NAM traces, are written into 7.nam. Okay, 7.tr for general traces, 7.nam for the network animator traces. Okay, so the next step, creating the nodes. So we need to create 6 nodes. So we are creating N0, N1, N2, N3, N4, N5. Total 6 nodes we create here, and then we are going to create links. Okay, so duplex links between N0 to N2, N1 to N2, and then N2 to N3, N3 to N4, N3 to N5. So N0, N1 are connected to N2, N2 is connected to N3, and N4, N5 are connected to N3. Okay, so we will see when we run, we will see how the network looks. And then we are setting the queue limit, that is the buffer size. So between N2 and N3 buffer size is 3, between N3 and N2 buffer size is 3. And then so we, in the previous programs, we had created TCP agents, we had created UDP agents and TCP sinks, null agent, different agents we had created. Now for sending the ping messages, we are going to create ping agents. Okay, so we are creating new ping agent, and storing it in ping 1, and similarly ping 2, ping 3, ping 4. So now both source and destination, okay, it's actually in this ping message scenario, there is no fixed source and fixed destination. What happens is, one node sends a ping message, another node will reply back. So when one node sends a message, source will be that node, and whoever receives will be destination. Now destination will reply back. So destination will become source and source becomes destination. So there is no sync concept here. So we make all of them as ping agents. And then we attach this ping 1, we attach it to N0, ping 2 to N1, ping 3 to N4, ping 5 to N, ping 4 to N5. So now we have made 4 ping agents. 4 nodes are nominated as ping agents, and now N2, N3 are just intermediary nodes. They are like the routers. Okay, so they are not source or destinations, they are just kind of routers. And then we define a procedure to print RTT. So round trip time. RTT is round trip time. So what is the time it taken? That is for sending the message and getting a reply back. The total round trip time. What is the round trip time? We need to display it on the screen for our understanding. So for that we are creating a procedure, or we are creating a function called inst proc, and here we are printing it. So from which node to which node, what is the round trip time? So we are just printing it here. We send so many ping messages throughout when we run the animations. So for every ping message, what was the round trip time? We just understand that here, or we just get to see it here on the screen. And then we need to connect. Okay, so till now we have created nodes and we have created links. Now ping messages, which is the source and which is the destination. So we are connecting. We are making two connections, one from ping 1 to ping 4. Ping 1 to ping 4 means N0 to N5. N0 to N5 we are creating one connection. Another between ping 2 to ping 3. Ping 2 to ping 3 and N1 to N4. So one connection between N0 to N5. Another from N1 to N4. Okay. So now we are creating two classes, class 1, class 2. So class 1 will have higher priority, class 2 will have lower priority, and this is the finish. In the last previous programs we had given the name as finish for this particular function. Here we are giving end. So it just does nothing, it just flushes the trace, that it writes everything into the trace, and we close the two trace files that we opened at the beginning, and then we execute the network animator and exit the program. Okay, so the final part, as we already know, we need to schedule. Okay, so till now the scheduling was working in a way, it was like a sequence. So start something at this particular second, then start something at this particular second, and after some gap stop them. But here ping messages, we need to send ping messages repeatedly. Okay, we need to send ping messages continuously. So for that purpose we are having a for loop here. Okay, so the syntax is different here, but it is very simple one. So if you want to understand it in a more better way, I'll write a similar code how we can write it in Java or C++, so it will give a better understanding. So it is like for t equals to 0, t is less than 5, t equals t plus 0.001. Okay, this is how we write it in Java or C. Same thing is written here in TCL. Okay, there is no difference. So what we are doing, set t equals to 0, and then if t is less than 5 is the condition, and then set t expression t plus 0.001. So it is like this. So a t value in the first iteration, t value will be 0. In the second iteration, t value will be 0.001. In the third iteration, t value will be 0.002, 0.003. So it goes on up to t is less than 5. That is, it will go up to t is maybe 4.999. Okay, it will go up to t is equals to 4.999. Okay, when it becomes 5, it comes out of the loop. Okay, so inside loop, what are we doing? We are just doing, there are two connections we have made, ping 1 to ping 4, ping 2 to ping 3. So ping 1 we are sending, and then ping 2 we are sending. Okay, at $t. So $t keeps incrementing. At that particular time, ping 1 will also send, ping 2 will also send. So what happens is, starting from the time 0, we keep sending. So both ping 1 and ping 2, ping 1 and ping 2 are N0 and N1. Both N0 and N1 keep sending the pings continuously for every 0.01 second. So that's what this loop does. Okay, so this runs for 5 seconds, and at 5th second we call end procedure. End procedure is here, we discussed what it does, and then finally we run the simulation. Okay, I hope everybody have understood the program. So let's run the program and see how it works. the command for running, you guys are familiar, NS network simulator. The program name what I have given is p7.tcl. okay, NS p7.tcl. if I run it, see here, so many ping messages are going. So we just wrote this. Let me go back to the code. Okay, where did we? Okay, so see here, so this is the print message that we put from node to this node, and this is the RTT. Same thing is getting printed for every ping message. So node 1 to node 4 round trip time was 9.4 millisecond. Node 0 to node 5, there are only two messages are going, one from node 0, one from node 1. Okay, node 0 to node 5, node 1 to node 4. So ping messages are going continuously between those two nodes. So here you can see the round trip time for every different ping messages. So it started at 0th second and it ends at 5th second, and there will be ping messages going from node 0 and node 1 for every 0.001 second. Okay, so now let's look at the animator comes up here. So as soon as I start, both 0 and 1 start sending the ping messages. So we created 6 nodes, N0, N1, N2, M3, N4, N5. So one connection between 0 to 5, another between 1 to 4. As I already said, 2 and 3 are just intermediary nodes. They are like the router. So let's run it. You can see there is color coding also. Let me slow it down. Okay, so one is sending the green color pings, and 0 is sending red color pings. Okay, 1 is sending green, 0 is sending red color pings. So you can see, so these two links are faster, but this link is slower, and these two links are better, faster than these. So that's when we created the links, we actually defined the speed. Okay, so and whatever the coming back in the black color are acknowledgements. Okay, so there are pings going, and you can observe at the node 2 there are some packets getting dropped because there is a congestion or the buffer size is less. So you can alter the speed, buffer size, and try and see how the packets dropping can be reduced. You guys know AWK code for counting the packets dropped. We did it in the program 5. So you can run the same AWK code and check how many packets are getting dropped. This is how we simulate the ping messages, and this will continue for 5 seconds. So let me fasten it. So it goes, let me slow down now. Okay, it goes till 5th second and then it stops.